you have so that we can wrap them up today. Let's start with this. Okay, everyone, let's begin then. So we were doing differentiation, and today we want to do some more practice questions on this topic. If you have any problems from the worksheet, let me know about them. We will discuss those problems one by one. So please make sure to write them in the chat box right now so that I can have a look at the questions, and then we can decide the order in which we're going to do them. So I'll try to do them in the order of increasing difficulty so that we gradually get up to speed. So question number 12, 22. Okay, 33. All right. 35. Okay. All of these look like good questions. Okay. Any other questions from the worksheet as well? Can you post those as well? Any other questions from the worksheet? I just need to decide the order in which we're going to be doing that. So I've looked at the ones that you've posted already. So let me know if you have any other questions apart from this as well. So I can just look at them right now. Then we could decide the order in which we're going to do them. $36, $39. I hope you've attempted these questions as well, and it's not that you're just looking at the questions and saying that, okay, it looks difficult, so we might just try this. So I hope you've attempted these questions and then you're having problems, and that's why you're asking, because that's really important. Otherwise, I'll just solve them for you. But then when you try doing more questions yourself, if you haven't been practicing yourself, you would end up being stuck again, right? So you learn the best when you attempt questions, and then you get stuck somewhere, and then you ask about that, and then when it gets clarified, you retain that for long. But if you just want me to solve everything for you without you doing much, then it might not be something that you're able to retain for very long. Okay, so make sure that you've attempted these questions already, and then once I explain them, hopefully you'll understand them better. Okay, so let's start with some of these questions then. So let's start with some relatively simpler ones. So we could probably start with this one. This is question number 39 that Marina has posted. Let's start with this one. And then we'll gradually increase the difficulty level. Okay, question number 39 from the worksheet. Let's have a look at this. Question number 39. Okay, so it says equation of a curve is y equals 3 cos 2x plus 7 sin x. 3 cos 2x plus 7 sin x plus 2. Find the x coordinates of the stationary points in the interval 0 to pi, give each answer correct to three significant figures. So we're basically looking for x coordinates of the stationary points of this function. All right, so we have the function given. All we have to do is differentiate it, put the derivative equal to 0, right? So we're looking for stationary points. What does that mean? We're looking for points where the gradient of the function is equal to 0. So that's what we're going to do. Let's find the derivative and see what we get from that. dy over dx. Now it's a simple function, 3 cos 2x. What's the derivative of that? The constant remains as it is. What's the derivative of cos of 2x? Derivative of cos is minus sine, so it becomes minus sine 2x multiplied by 2. All right, that's the derivative of 3 cos 2x plus 7 into sine x. 7 is the constant being multiplied. Sine x, what's the derivative of sine? Derivative of sine is cos, so it becomes 7 times cos x. And 2 becomes 0 when differentiated. All right, so that's the derivative. We just put that equal to 0. What does that give you? That gives you minus 6 sine 2x plus 7 cos x. Now you just have to solve this equation, and you need to find the x coordinates of this equation that satisfy the values of x are supposed to be between 0 and pi. Now, after this, it's just a trigonometric question. Differentiation part is done here, right? There's no more differentiation after this. It's just a simple trigonometric equation that you need to solve. So it's more of trigonometry after this point, right? So let's do this quickly. So how do you solve equations like these? You have one sine function, one cos function. The problem is one angle is 2x and the other is x. So you need to convert this equation to a form such that you only have one type of angle. So you can apply the double angle identity for sine. What does sine 2x become? Sine 2x is going to become 2 sine x cos x. Remember the identity for sine? So we know that sine of 2a, that is identical to 2 sine a into cos a. All right, that's the double angle identity for sine. So what does this become then? Minus 6. We could write sine 2x as 2 sine x cos x. And then you have plus 7 cos x. This equals 0. So now we have this equation, minus 12 into sine x into cos x plus 7 cos x equals 0. So now we have only one type of angle. We have x, right? Single angle throughout. How do we solve this equation? Now we can take cos x common. If we take cos x common, what are we left with? Minus 12 sine x plus 7 inside the brackets, and this product equals 0. Now we have cos x multiplied by minus 12 sine x plus 7 equal to 0. That means either cos x is supposed to be equal to 0 or minus 12 sine x plus 7 is supposed to be equal to 0. So we get two equations from this. We get either cos x equals 0 or minus 12 sine x plus 7 equal to 0, right? So these are two equations that we have. Let's solve the first one. Cos of x equals 0. What's the interval that we're given? From 0 to pi. You can find the basic angle and see what that turns out to be. Cos alpha equals 0. What's the basic angle? Just do that in your calculator. You can think of the graph of cos in your head as well. When is cos 0? Cos is 0 at 90 degrees, right? In radians, that would be pi over 2. So within this interval from 0 to pi, the angle that you should be getting should be pi over 2. So the basic angle is pi over 2. And then you can think of, okay, cos is positive in the first and fourth quadrants, negative in these two quadrants. Pi over 2 is in the middle. 0 is supposed to be between negative and positive signs. So that means it could either be here or it could be here. Both of these possibilities are there. The angle could be pi over 2. The angle could also be 3 pi over 2. However, 3 pi over 2 is going to be outside the interval. So we only consider pi over 2. So that's the one possible answer that we have. We have x equals pi over 2, right? That's one possible answer. Let's solve the other equation. What do we get from that? Sine x equals 7 over 12. Again, you find the basic angle. sine alpha equals 7/12. What's the basic angle that we get for this? Sine inverse of 7/12, make sure your calculator is in radian mode. Okay, so this is giving me 0.6228. That's the basic angle that we get from the second equation. Now, in this case, sine is positive, right? In the first case, it was 0. 0 means it has to be between negative and positive values. So between negative and positive, that means this was positive, this was positive, this was negative, this was negative. So between positive and negative, that means it was supposed to be on this line. Now on the right side, in the case of sine, sine is supposed to be positive. Where is sine positive? Sine is positive in the first quadrant and in the second quadrant. So these are the two possibilities that you have. Alpha could be here or it could be here. And the interval is from 0 to pi. That means both of those quadrants could give you some values. So you have one value in the first quadrant, that's going to be 0.6228. And in the second quadrant, it's going to be pi minus 0.6228. And that should give you some result as well. You have three possible answers from this. Pi minus this, that's going to give you 2.5185187. And these are three possible values of x that you have. Okay. Now the question asks you to give each answer correct to three significant figures. When they specify the level of accuracy in the question statement, that means it's necessary for you to follow that. Otherwise, you could write more decimal places as well, and that would be okay. But in this case, since they have specified this in the question statement that your answers have to be correct to three significant figures, so you should write them correct to three significant figures. Now, you could get away with writing pi over 2 like this because that's an exact number. But since they've said three significant figures, it's a good idea to write that in decimals as well. Let's see what that turns out to be. Pi divided by 2, that's 1.57. So one possible value that I'm getting is 1.57. That's one possible value of x. And then we have x equals 0.623. That's another possible value. And then the last one is x equals 2.52. That is 2.518723 significant figures, 2.52. These are three possible values of x that we get from this. And that's it. That's all that we had to do here. That wasn't that very difficult. Any problem with this? Any questions, anyone? Does this make sense? Marino, so the question is, when do we consider negative values when finding angles? Well, you consider negative values when finding angles when the interval has some negative values. So in this case, the interval is from 0 to pi. So that's all positive values, right? So if the interval was, let's say, minus pi to pi, or maybe minus 2 pi to 2 pi, if you had negative values in the interval that was given, then you consider negative angles by going clockwise as well. Then you do that. But since the interval that's given in the question that only has positive angles, we only consider positive angles. Is that okay? All right, good. Let's have a look at the next one now. So this was a relatively straightforward start. Now let's try to gradually increase the difficulty level. Now that was question number 39. Okay, so next one you're asking about is 36. Let's have a look at this. Question number 36. Okay, let's try this now. So the diagram shows this curve x squared plus y squared whole squared, that equals 2 into x squared minus y squared, and one of its maximum points m. So we have this curve and we have one maximum point given here that has this name called, that's basically labeled m, okay? We need to find the coordinates of m. So what we are looking for is the coordinates of this point m. Now, what's M? M is the maximum point of the curve. Maximum point means it's one of the turning points, one of the stationary points. How do we find stationary points of any function? At the stationary point, we know that the gradient is equal to 0. Since the gradient is equal to 0, we have to find the derivative of this function and put that derivative equal to 0. That's all that you've got to do. Now, how do you find the derivative of this function? So basically, we want to find dy over dx, right? That's what we want to figure out. Now, this is a function in which y is not the subject. Since y is not the subject, remember the method that we use for differentiating this function, we would have to use implicit differentiation. All right, we'd have to use implicit differentiation to find dy over dx here. Let's see how that is going to work here. So on the left side, we have x squared plus y squared whole squared. On the right side, we have 2 into x squared minus y squared. Let's start differentiating. Now, on the left side, what kind of function is this? What's the outer function? Remember, we said we're going to start from the outermost function when we are differentiating. The outermost function is the power function here, right? Because we have this square outside. So which rule do we apply? We apply power rule on this. Now, what does the power rule say? You multiply by the power. So you multiply by 2. Subtract 1 from the power. So whatever is inside, that remains as it is. You subtract 1 from the power. So the power becomes 1. Okay. And now you multiply by the derivative of the base of the power. So now we need to multiply by the derivative of this expression. What's the derivative of x squared plus y squared? Remember, we are differentiating with respect to x. That's what we're doing. Let me actually write this down here for your notes. What we're doing is we are differentiating both sides. We are differentiating both sides with respect to x. That's what we're doing. Now, what's the derivative of x squared with respect to x? The derivative of x squared is going to be 2x, right? So inside brackets, we have 2x. What's the derivative of y squared with respect to x? Remember, when we are differentiating x squared, what we're saying is we multiply by the power, that is 2. Subtract 1 from the power, so power of x becomes 1. And then multiply by the base of the power. What's the base? Base is x here. What's the derivative of x with respect to x? That's 1. So you could say you're actually multiplying by 1 here, right? So 2 into x into 1. But now, when you take the derivative of y squared, what is that going to be? Again, apply the power rule. Multiply by the power, you multiply by 2. Subtract 1 from the power, it becomes y raised to the power of 1. And then you have to multiply by the derivative of the base of this power. What's the base? Y. What's the derivative of y with respect to x? Derivative of y with respect to x is dy over dx. That is what we have on the left side. All right. So we should kind of remember whenever we have y, we would have to multiply by dy over dx there when we are multiplying, when we are differentiating with respect to x. Okay, so that's the left side done. What about the right side? Now, on the right side, you have this constant multiplying with the whole expression, a constant multiplying with the whole expression that remains as it is. That's not going to change. So 2 remains as it is. What about the derivative of x squared minus y squared? Derivative of x squared, again, is 2 into x into 1, if you like, minus 2 into y, but then multiply by the derivative of y. What's the derivative of y? It's dy over dx. So now you have differentiated this function. You've differentiated both sides of this function. Now, if you had to find the derivative, if they had asked you to find dy over dx for this function, you would simplify everything. Then you would take all the dy over dx terms to one side, take dy over dx common, and take everything else to the other side, and that will give you dy over dx, right? But here they have not really asked us to find the expression for dy over dx. All they're looking for is this maximum point m. That's all they're looking for. Now, how do you find that maximum point? We have to find the maximum point by putting dy over dx equal to 0. Now, we can actually save some effort. We don't really have to make dy over dx the subject here. We can put dy over dx equal to 0 right away. We can just put dy over dx equal to 0 right in this step. Okay, that will save us some working, And also it'll save us careless errors while we do that working. Just put dy over dx equal to 0 right after you have differentiated it, right? Let's see what we get from that. 2 into x squared plus y squared. And then inside, we have 2x plus 0, right? 2y into 0, that's going to become 0. On the other side, we have 2 into 2x minus 0. That's an equation that you have now. Let's simplify everything. That gives us 2 into x squared plus y squared. Or you can actually multiply this 2 with this 2x. What does that give us? That gives us 4 times x into x squared plus y squared. On the other side, we have 4 times x. That's the equation that we get. Okay. Now, you might be tempted to cancel 4x and 4x out, but that's not something that I would recommend you make a habit of doing, because cancellation means that you're dividing 4x on the other side. But that could be a problem, because what if the value of x was 0? X is a variable, right? We have to be careful when we're dividing by x, because x could also take a value of 0. If x was 0, this would become undefined. All right. So we should not generally divide by x. All right. So the proper way of doing this would be, you take this 4x to the left side. So it becomes 4x into x squared plus y squared minus 4x equals 0. And now you take 4x common. When you take 4x common, what are you left with inside? X squared plus y squared minus 1 equals 0. Now that means either 4x equals 0 or x squared plus y squared minus 1 equals 0. You get two equations from this, either x equals 0 or x squared plus y squared equals 1. All right. So what have we done until now? We have differentiated both sides, put the derivative equal to 0. When we put the derivative equal to 0, we get either x equal to 0 or x squared plus y squared equals 1. All right. That's the result that we've got. Now, what were we looking for? We were looking for the coordinates of M. Now, if you think about it, M is right here. Okay. What does that tell us about the x coordinate of M and the y coordinate of M? They are both supposed to be positive, right? It's on the right side and above, which means x equal to 0, this is not possible. X equal to 0 would be here, this point. That's not what we are looking for. So we say this is not possible. X equal to 0 is not possible. At least it's not the point M. So we are not going to consider that. We're only going to consider this thing. X squared plus y squared equals 1. Now, this is one equation that we've got in terms of x and y. What do we do now? We say, let's solve this equation simultaneously with the original equation. We have another equation in terms of x and y. That was the original function, the original equation. We solve it simultaneously with that and find the values of x and y. Now, what was that equation? That was given in the question already. It was x squared plus y squared whole squared. That was equal to 2 into x squared minus y squared, right? That's what that function was. Now we have to solve this equation and this equation simultaneously, and that should give us values of x and y. Now, how do we solve these two equations simultaneously? This is x squared plus y squared equals 1. We have to make one of the variables the subject in one equation, put that in the other equation, okay? So let's make y squared the subject here, for instance. That gives us 1 minus x squared. Now you could try taking square root, but remember, when you take square root, you have to put plus minus. That's going to complicate things. In the other equation, you have y squared. So you don't really have to find y here. You can just put y squared in the other equation as it is, all right? What does that give you? When you put that in the other equation, that is going to give you x squared plus 1 minus x squared. So I'm putting y squared equal to 1 minus x squared. That gives us this. On the other side, we have 2 into x squared minus 1 minus x squared. Let's simplify this. Now on the left side, these two get cancelled and we're left with 1 equal to 2 into x squared minus 1 plus x squared, and that leaves us with 2 into 2x squared minus 1, that equals 1. And we have 4x squared minus 2 equals 1. 4x squared equals 3. X squared equals 3 over 4. Take square root on both sides, and that gives you plus minus. Remember, whenever you take square root, we have to put plus minus. So that's plus minus square root of 3 over 4. Or a simplified form for that, if you just put this on your calculator should give you under root 3 over 2. These are the possible x coordinates that we have in this case. Now that's basically giving us this x coordinate and also this x coordinate. So basically it's giving us all the turning points, right? We have one turning point here, one here, one here, one here. We were looking for m. M is supposed to have a positive x coordinate. So because of that, we say, let's just consider the positive value here. The positive value is square root of 3 over 2. Now you put this value in the other equation, and that's going to give you y squared equals 1 minus x squared. X squared was 3 over 4. You can actually just input that here, 1 minus 3 over 4. And that gives you y squared equals 1 over 4. Take square root on both sides. Again, you get plus minus 1 over 2. Here as well, we're going to consider the positive value. Why? Because the y coordinate of m is also positive. So we say y equals 1 over 2. And that gives us the coordinates of the point m. They are going to be under root 3 over 2 and 1 over 2. And that's what we were looking for, the coordinates of that maximum point m. Make sense? Any problem with this? Any questions? No problems? Okay, good. Let's have a look at the next one now. So this was question number 36. Okay, let's try another one. Okay, so the next one that you're asking about is question number 12, 22, 33, 35, and 8. Okay. Okay, let's do this one. This is question number 22 from the worksheet. Again, it's like kind of average difficulty, it seems, or yeah. Let's try this. Question number 22 from the worksheet. Okay, so this is the equation of a curve is y equals 3 sine x plus 4 cos cube x. We need to find the x coordinates of the stationary points of the curve in the interval 0 to pi. Again, we're looking for the stationary points, right? So all we have to do is differentiate this function. Y equals 3 sine x plus 4 cos cube x. We're looking for the stationary points, the x coordinates of the stationary points. All we have to do is find the derivative of this function. Now, cos cube x, what does that mean? Remember, we talked about this before. The proper mathematical way of writing this is cos of x whole cube, right? Cos cube x is just a short form for cos x whole cube. So it's actually a power function. All right. So when you differentiate it, what is this going to become? The derivative of sine is cos, so that becomes 3 into cos x. What about this? This is the power function now. 4 outside remains as it is. Multiply by the power, subtract 1 from the power, multiply by the derivative of the base of the power. This is the base, cos x. What's the derivative of cos? The derivative of cos is minus sine. So we multiply by that. Let's simplify this, and that's going to give us 3 cos x minus 12 cos square x into sine x. And since we're looking for the stationary points, we put this equal to 0. We put dy over dx equal to 0 here. How do we solve this equation now? Let's think about this. We could either convert everything to sine or cos, or can we actually do that? Let me think about it. Let's actually first simplify this a bit. It's going to be 0 equals, if we divide the whole equation by 3, just to simplify this a bit, we're going to be left with cos x minus 4 cos square x into sine x. Now, we can't really convert it to one function as it is right now, because if we were to try converting cos square to sine square, we would still have this cos left. What we can try doing is we can take cos x common, perhaps. Let's start with that. If we take cos x common, that leaves us with 1 minus 4 cos x into sine x. That equals 0. Okay. Now, it's a product. Cos x multiplied by 1 minus 4 cos x into sine x. Since this product is equal to 0, that means either cos x should be 0 or 1 minus 4 cos x into sine x should be 0. So that gives us either cos x equals 0 or 1 minus 4 into sine x into cos x equals 0. And that gives you 4 sine x into cos x equals 1. Now we'll come to this, come back to this in a moment. Let's look at this for first of all, it's pretty straightforward. Cos of x equals 0. What's the interval that we're given? The interval is from 0 to pi. Now you can just think of the graph. When is cos 0 in this interval? The cos graph starts from 1 and then it goes to 0 when it's pi over 2, and then it goes to minus 1. So basically cos x 0 is going to be when x equals pi over 2. So that's going to give you one solution right away. X equals pi over 2. That is one possible answer in the interval that's given, right? The interval is from 0 to pi. So one possible value of x that we get from this is pi over 2. Now the problem is, how do we solve this equation, the other equation? Remember the rule that we discussed in trigonometry. When we are solving trigonometric equations, we need two things to happen. One, there should be only one type of value, right? In this case, we have x and we have x. That condition is satisfied. And the second condition is that we should only have one type of function. We can't have multiple functions. We have sine x here, and we also have cos x here. We have both of those functions, sine and cos. Now, how can we convert it to one function? That is what we need to think about. How do we convert it to either only sine or only cos or maybe tan? Now, it's not very obvious. But if you know your trigonometry well, and if you've done a lot of practice of trigonometry, this product should actually remind you of something. Sine x into cos x. Have you seen this in the list of trigonometric identities anywhere? Sine x into cos x? Doesn't that remind you of something?
Sine 2x?
Sine 2x, the identity, that the double angle identity that we have for sine, right? It's basically that. We know that sine of 2a is identical to 2 sine a into cos a, right? That's the double angle identity for sine. Now, this looks kind of similar to that. If we were to write it as this, 2 into 2 sine x cos x, right? We can do that. We can write 4 as 2 multiplied by 2. So it becomes 2 into 2 sine x cos x. That equals 1. Now, this thing is basically sine 2x. That's what we can do here. We can say 2 into sine of 2x, that equals 1. And now sine 2x equals 1 over 2. That's the equation that we end up getting from this. Yeah, so Roman, we could do that as well, divide both sides by 2. Yeah, so that could be another idea as well. We could divide both sides by 2. and that would give us 2 sine x cos x equals 1 over 2, which we could then convert to sine 2x equals 1 over 2. All right. So now we have only one type of function, which is sine of 2x. All right. And there's only one angle, right? 2x. Now we can solve it. You can use substitution here if you want. You can do it without substitution as well. However you want to do it. Remember, you have to adjust the interval. However, what's the interval that you're given for x? The interval given for x is 0 to pi. The angle here is not x. The angle is 2 times x. What's the interval for 2x? The interval for 2x is from 0 to 2 pi. So when you're looking for angles in using quadrants, you have to make sure that you look for angles from 0 to 2 pi, right? One full circle. Now, keeping that in mind, now let's find the basic angle. What's the basic angle? Sine inverse of 1 over 2. And I think it's pi over 6, right? 30 degrees. Yeah, so pi over 6. That's the basic angle that we get. Now, think of quadrants. Sine is supposed to be positive here. Positive means we can be in this quadrant or in this quadrant, right? In the first and second quadrant, sine is positive. So alpha could either be here or it could be here. So what are the values that we get then? Pi over 6 or pi minus pi over 6. But remember, these are not values of x. These are values of 2x. So we say 2x either equals pi over 6 or 2x equals pi minus pi over 6. And that gives us x equals pi over 12 or x equals 5 pi over 6 divided by 2. That's going to be 5 pi over 12. These are the 3 possible values of x that we get from this. X equals pi over 12, equals 5 pi over 12, or it equals pi over 2. These are the three values of x that give us at which we have stationary points. Make sense? Any problem with this? No questions? All right, let's have a look at another one then. Okay, just give me a second. I need to check my internet connection on the other device. It seems to be some issue. Okay, that's fine. All right, let's have a look at the next one then. So the next one that you're asking about is okay, so we're done with 22. Now let's actually start the harder ones, the real harder ones, real hard ones. So you have 12, 33, and 35. Okay. Let's start with this one, 33. This is question number 33 from the worksheet. Let's have a look at this. Okay, question number 33 from the worksheet. So it says the diagram shows the curve y equals 10e raised to power minus half x into sine of 4x for x greater than or equal to 0. The stationary points are labeled T1, T2, T3 as shown. Find the x coordinates of T1 and T2, giving each x coordinate correct to 3 decimal places. Okay, so this is the function that we've got. Y equals 10e raised to power minus half x into sine of 4x. That's the function. And we have these stationary points, T1, T2, T3, T4, and it's going on like this. So this curve basically continues like this, right? So on. So there are many stationary points. They're actually infinite stationary points because it just keeps going on and on like this. All right. Now, what they're asking for in the first part is, They're asking for the x coordinates of T1 and T2. Now, what are T1 and T2? T1 and T2 are the first two stationary points. So we are looking for stationary points. Now, we can't find all of them because there are infinitely many. They're just asking us for the first two, all right, T1 and T2. So we have to find stationary points, right? How do you find stationary points of any function? You find the derivative, put that equal to 0 because the gradient is supposed to be 0 at the stationary points. Let's start with differentiation. So we have 10 e raised to the power minus half x into sine of 4x. This is the function that we've got. All right. Okay. Now, how do you differentiate it? It's a product. So when you're differentiating, you'll have to use the product rule. Now 10 is a constant. You can just keep it outside like this and then apply the product rule. Remember, what's the product rule? uv dash plus bu dash, the derivative of uv, that is uv dash plus bu dash. Now we're considering this as u and this as v. Now actually just write that down here to make it simpler to understand. We're calling this u and this v. Okay. So uv dash, u as it is, that means e raised to the power minus half x, that remains as it is, into derivative of sine of 4x. What's the derivative of sine? Derivative of sine is cos, so it becomes cos 4x. But then you have to multiply with the derivative of this thing. What do you have instead of x? You have 4x. What's the derivative of 4x? That's 4. This is uv dash plus vu dash. Now v as it is, that means sine of 4x as it is, into derivative of u, which is e raised to the power minus half x, right? The derivative of e power something just remains the same, e power that thing. However, then you have to multiply by the derivative of this thing. What's the derivative of minus half x? It's minus half. So this is the differentiation of this function. This is the differentiation of this function. dy. Okay, so this is the derivative. This is the derivative. E power minus half x into cos 4x into 4 and so on. This is the differentiation, all right? Now, since we're looking for stationary points, all you have to do is put the derivative equal to 0. Put the derivative equal to 0. Okay, that's what we do. So we have 0 equals 10 into 4 e raised to the power minus half x into cos of 4x minus half into e raised to the power minus half x into sine of 4x. This is the equation that we now need to solve. Okay. Now, how do we solve this? We can multiply this 10 inside. You can actually divide it on the other side as well if you want. But I would actually want to remove the fraction on the right side. So in order to remove the fraction on the right side, I'm just going to multiply this inside. Let's see what we get from that. We have 40 e raised to the power minus half x into cos 4x minus 5 e raised to the power minus half x into sine 4x. That equals 0. Now we need to solve this equation. How do we solve this equation? We can take e power minus half x common, right? Let's see what we get when we do that. And we can take 5 common as well, actually. 5 e raised to the power minus half x. If we take that common, what are we left with inside? 8 cos 4x minus sine 4x. And this equals 0. Now it's a product and the result is 0. That means either 5 e raised to the power minus half x should be equal to 0 or 8 cos 4x minus sine 4x should be equal to 0. Now, the first equation is not going to give us anything because e is a positive number. E raised to the power anything, a positive number raised to the power anything can never give us 0. But you can try that if you want. You can try taking log on both sides. On the right side, you would have log of 0. That's undefined. So basically, you don't get anything from this. This is not possible. From the first equation, you're not going to get anything. What about the second equation? Again, it's a trigonometric equation. We have one cos function, one sine function. The angles are both the same. Can we convert it to a single function? What we can do is we can take sine 4x to the other side and then divide this cos 4x on the other side as well. So that gives us sine 4x over cos 4x. That equals 8. On the right side, now we have tan. So that becomes tan of 4x equals 8. And now we can find the values of x from this. Now, what's the interval that we've got? Now, the interval that's given is x greater than or equal to 0. So all we know is that x is supposed to be some positive value, right? So on the diagram, you can see it's some positive value, but there's no upper limit given. Since there are infinitely many solutions, what we have to do is we have to find the first two values of x that we get on the positive side. That's all that we've got to do. So on the positive side, we are looking for the first two stationary points. So we just find the first two positive values. And that is going to give us the x coordinates of t1 and t2. All right, so that's all that we've got to do. First two positive values, okay? Now keep that in mind, find the basic angle. What's the basic angle? Tan alpha equals 8. Let's see what the basic angle turns out to be. Remember, you have to use radians, don't use degrees, please. Tan inverse of 8, that's giving me 1.4464. This is the basic angle that I'm getting, okay? Now, tan is positive. Where is tan positive? Tan is positive in the first quadrant and in the third quadrant, yeah, right? It's a positive value of tan. So we could either be in the first quadrant or in the third quadrant. Now, the basic angle could either be here or it could be here. These are the two possible basic angles that we could have, either in the first quadrant or in the third quadrant. Now, where do we start measuring angles from? The positive x-axis, right? So first two positive values, that's all that we want. This is the first positive value. What's that going to be? 1.4464. And the second positive value is going to be this one. What's that? That's going to be pi plus 1.4464. And that's going to give us the x coordinates of the first two stationary points. All right. Now, the angle was not x. The angle was 4 times x here. So we say either 4x equals this or 4x equals this. The first one gives us 0.3616, and the second one gives us pi plus 1.4464 divided by 4, and that is 1.14699, so 1.147. Now, does it give us any instruction? It says give your x coordinates to 3 decimal places. Now, you have to make sure that you follow that instruction. 3 decimal places, so it's going to be x equals 0.362 and x equals 1.147. It's not 3 significant figures, it's 3 decimal places. Now, if a question statement gives you an instruction like this, you have to make sure that you follow that instruction. Otherwise, it's not good. You are going to lose 1 mark for the wrong level of accuracy at the end. Okay, so you have to make sure that you follow that instruction given in the question. All right, now let's look at the second part. So that was the first part, right? We have the x coordinates of t1 and t2. That's all that we were looking for. Okay, now what's the second part? Let's see what the second part is. It says it's given that the x coordinate of Tn is greater than 25. Find the least possible value of n. Now, what does that mean? It's given that the x coordinate of Tn is greater than 25. Find the least possible value of n. Now, what's Tn? You see, the turning points, the stationary points are marked like this: T1, T2, T3, T4. It's going to continue like this, right? So we are only shown part of this graph. the graph continues like this. So you have this and this and this like this. Now the next turning point is going to be T5, and the next one after that is going to be T6, and then T7, and so on. It continues like this. At some point, they're saying there is Tn. And that Tn, the x coordinate of that Tn, that is supposed to be greater than 25. What's the least possible value of n? That's what we want to find out. Now we have two turning points already. We have T1, we have the x coordinate of T1, we have the x coordinate of T2. Let's write them down here. So the first x coordinate is 0.362. What about the next one? That's 1.147. We found this as well. Now, what about the next one? How are we going to find the next x coordinates after this? T3, T4, T5. If you look at this diagram, the remaining x coordinates are basically going to come like this. So this is the first one. This is the second one. How do you go to the next one? Remember, they're all positive, all on the right side. These were the first two that we found. The next one is going to come like this. We will go one full circle and then come back to this point. That's going to give us T3. And then what about T4? We'll go one full circle. This is T3, and then this is T4. So basically, we keep going around in circles. Every time we come back to this line, we will have the next x coordinate. Okay, so we have T1 and T2 already. This is T1. This is T2. How do you find T3? T3 would be one full circle. How much is that? 2 pi. And then add to that the basic angle. What's the basic angle? The basic angle is this, which is 1.4464. This is going to give us T3. Let's find that out. Let's see what that is. 2 pi plus 1.4464 divided by 4, and that's giving me 1.932. Now, if you notice, the x coordinate of T1 is 0.362. That's the x coordinate of T1. And then the x coordinate of T2 and T3, they are 1.147 and 1.932. Now, if you notice how we are calculating those x coordinates from this diagram, from the quadrants, basically the first one is this. And then how do you get the next angle? You add pi to it to get the next angle. Then you add pi more to get the next one. You add pi more to get the next one. You add pi more to get the next one, right? So the angles are coming like this. You're adding the same number again and again. And then that angle is 4 times x, so we divide by 4 at the end as well. But the idea is we are adding the same thing over and over again to get the next x coordinate of the stationary point. So if you were to find the difference between these values, you would see that that difference is constant. You can try evaluating this. 1.147 minus 0.362. Since we were adding the same thing over and over again, this difference is coming out to be 0.785 for me. Try this as well. 1.932 minus 1.147. This is also 0.785. So this is kind of becoming an arithmetic progression, an arithmetic sequence. Remember that from paper 1? So this can also come in paper 3 sometimes. In fact, everything that you've done in paper 1, that's a prerequisite for paper 3. So you could be tested on anything from paper 1 and paper 3 as well. Now, of course, some topics get tested more, but you could get anything basically. Okay, so that's possible. So those of you who are appearing for A2 exams and have given AS already last year, you should still revise your paper 1 as well, because sometimes you end up getting tested on some concept that is not usually tested, but it ends up coming. Now, this is a relatively simple one, just an arithmetic progression. You're basically looking for Tn. the nth term of this arithmetic progression. They're saying the nth term of this progression should be greater than 25, right? That's what they want. Now, what's the nth term of this arithmetic progression? We know it's an AP. It's an AP with the first term equal to 0.362 and difference equal to 0.785. What is the nth term going to be like? Nth term of an arithmetic progression that's given by this. It's given in the formula sheet, a plus n minus 1 times d. Just input values here. That's 0.362 plus n minus 1 times the difference. This is the nth term. They are saying this nth term has to be greater than 25. So you put this greater than 25 and you solve this equation and see what that, solve this inequality to see what that gives you. 0.362 plus 0.785 times n minus 0.785 on the other side, you've got 25. 0.785 times n, that is greater than 25 plus 0.785 minus 0.362. And on the other side, I'm getting 25.423, and that gives us n greater than 32.39. So n is supposed to be greater than 32.39. That's what we get. Now, they were asking us for the least possible value of n. Now, n is supposed to be an integer, right? Because n represents the number of stationary points. So we have t3, t4, t5. So n is an integer. Now, n is supposed to be greater than 32.39. What's the least integer greater than 32.39? That's 33. So we say the least possible value of n greater than 32.39, that is 33. Okay, that's the least possible value of n. Make sense? You don't have to round this off. If you were to round it off, that would become 32. It says greater than 32.39. So greater than 32.39, the least integer that you have is 33. And that's supposed to be your final result here. Okay, make sense? Any problem with this?
Sir, how did we find the value of d?
We're just subtracting them. T2 minus T1, that's also 0.785. T3 minus T2, that's also 0.785. So in an arithmetic progression, the difference is constant, right? So just find the difference of any two consecutive terms, subtract the previous term from the next term, and that gives you the difference. So basically, we're doing this here. 1.147 minus 0.362, and that's giving us 0.785. Okay?
Okay, sir.
All right, good. So that's question number 33. Let's move on to the next one. Okay, so the next one is question number 12. Okay. All right, let's try this now. Question number 12 from the worksheet. Now, again, it's a relatively complicated one. Okay, so we have this diagram that shows the curve y equals square root of 1 minus x divided by 1 plus x. This is a curve that we've got. Now it says by first differentiating 1 minus x over 1 plus x, obtain an expression for dy over dx in terms of x. So we need to find dy over dx in terms of x. But for that, they want us to first differentiate this thing, 1 minus x over 1 plus x. And then it says, hence show that the gradient of the normal to the curve gradient of the normal to the curve at the point xy, at a general point xy, that is given by this. Okay, now let's do it step by step. So there are three different things that they're asking us here. You first have to differentiate this thing, then find dy/dx, and then find the normal gradient of the normal and show that that equals this. So let's do it step by step. Let's first differentiate this thing that they've asked us to do. Derivative of 1 minus x over 1 plus x. So differentiate 1 minus x over 1 plus x with respect to x. That's the first thing you've got to do. We are not differentiating this function, remember? We're just differentiating this fraction for now. 1 minus x over 1 plus x. That's all that we're doing. Okay, now it's a fraction. How do you differentiate fractions? We know the rule for that. U over v. If you have a fraction like this, the derivative of that is given by vu dash minus uv dash divided by v squared. All right, so we just have to use that rule here. Numerator is u, denominator is v. So v remains as it is, first of all. So we have 1 plus x multiplied by derivative of numerator, u dash. So this is u, this is v. What's u dash? 1 minus x, derivative of that is minus 1. So we have minus 1 here. Subtract from that vu dash. V as it is, that means 1 plus x. Make sure that you write this in brackets. 1 plus x into u dash, which is, sorry, uv dash. I'm sorry, this is uv dash. U as it is, that's 1 minus x into v dash, derivative of denominator. What's that? That's 1. This is what you have in the numerator here. And then in the denominator, you just have v squared, and that's going to be 1 plus x whole squared. Now we could simplify this. 1 plus x into minus 1, that's going to be minus 1 minus x minus 1 plus x divided by 1 plus x whole squared. Minus x and plus x, they get cancelled. And we're left with minus 2 over 1 plus x whole squared. That's the first thing that we were looking for. We had to find the derivative of this thing. So we have found that derivative. Now the second thing that they ask us to do is find dy over dx, derivative of y with respect to x. Okay, that's the next thing that we've got to find. Now what's y? Y is this, right? This is the function y. Let's write that down here. Y equals square root of 1 minus x over 1 plus x. We could write this in power form so that it becomes 1 minus x over 1 plus x whole raised to power 1 over 2, right? In order to differentiate it, we first write it in power form. And now, how do you differentiate this function? It's the power function. We have to apply the power rule on this. dy over dx. Multiply by the power. Subtract 1 from the power. So 1 minus x over 1 plus x. 1 over 2 minus 1, that's minus 1 over 2. Multiplied by the derivative of the base of the power. So this is the base. 1 minus x over 1 plus x. You have to multiply by the derivative of this. Now, we have already done that here. We found the derivative of this expression. That is why they asked us to find the derivative of this fraction first. What's the derivative of this fraction? It's minus 2 over 1 plus x whole squared. So we just multiply by that here. We say this multiplied by minus 2 over 1 plus x whole squared. And that is dy over dx. We have just applied the power rule, right? Multiply by the power, subtract 1 from the power, multiply by the derivative of the base of the power, what is inside the power. Okay, that's what we get. Now let's simplify this. This 2 and this 2, they're going to get cancelled. The negative sign is going to remain there. So we have minus into 1 minus x minus into 1 minus x over 1 plus x whole raised to power minus 1 over 2 into 1 over 1 plus x whole squared. That is what we have. Now you could try simplifying this a bit. How do you do that? You could say it's 1 minus x whole power minus 1 over 2. In the denominator, this is 1 plus x. So you essentially have 1 plus x whole power minus 1 over 2. And you have power 2 here. These powers are going to get added. 1 minus 1 over 2 plus 2. What does that become? That becomes 3 over 2. This is what we have. This is dy over dx. You can leave it like this if you want to make this power positive as well by taking that to the denominator. You can do that, but it's okay to leave it like this as well. That is dy over dx. Okay. Is that okay? Any problem with this? So that's dy over dx. Now it says, hence show that the gradient of the normal to the curve at the point xy is 1 plus x into square root of 1 minus x squared. That's what we need to show. Gradient of the normal. What's the gradient of the normal? Normal is a line that is perpendicular to the curve at that point, right? Normal is a line perpendicular to the curve. So the gradient of normal is going to be negative reciprocal of this thing. Gradient of the normal is supposed to be negative reciprocal of this thing. That's all that you've got to do. Take negative reciprocal of this and see what that gives you. Okay, let's do that. Gradient of the normal. This is the gradient of the curve, remember? dy over dx, that represents the gradient function of the curve, right? If you had to find the gradient at any one particular point on the curve, you would just input that value of x and you would get the gradient at that point, okay? What about the gradient of normal? Normal is perpendicular to the curve. That means its gradient is going to be negative reciprocal of this. Change the sign and take reciprocal. So it becomes 1 plus x whole raised to power 3 over 2 divided by 1 minus x whole power minus 1 over 2. So I've just taken reciprocal of that and removed this negative sign. Now this negative power, if we were to bring this to the numerator, we could also write it like this: 1 plus x whole raised to power 3 over 2 into 1 minus x whole raised to power 1 over 2. That's what the gradient of the normal turns out to be. Okay. Now, if you were to just find the gradient of normal, you would just stop at this point and that will be your final result and that will be perfectly okay. But the problem is, they have asked us to show that the gradient of the normal is equal to this thing. 1 plus x into square root of 1 minus x squared. Now, how do we show this thing? Let me write that down. What you want to show is that it becomes 1 plus x into square root of 1 minus x squared. This is what we need to show. Now, how do you go from this form to this form? That is what the question is. Now we are almost there. It looks like that. So we have 1 plus x here, and they have 1 plus x here. However, they have power 1, we have power 3 over 2. And for some reason, somehow they have 1 minus x squared here. We just have 1 minus x. They have 1 minus x squared. Now let's see how we can go from this form to that form. Let's think about this now. Now, first of all, you see, you need 1 plus x here. You need 1 plus x whole power of 1. You have 3 over 2. What you can do is you can write it like this. You can say, this is power 3 over 2. Let's break it down into two parts. You could say power 3 over 2 could be written as power 1 plus 1 over 2. All right. So I could write it like this: 1 plus x whole power 1 into 1 plus x whole raised to power 1 over 2. And then we're left with 1 minus x whole raised to power 1 over 2 here as well. Now, why are we doing this? Because we want this 1 plus x separated, right? So we have 1 plus x separated. We have one part of what we want now, 1 plus x. And once you do this, that also makes the other thing easier to understand now, because you have 1 plus x into 1 minus x. That's an identity. A plus b into a minus b. That's a squared minus b squared. Since the powers are now the same, both powers are 1 over 2, we could multiply the bases, right? That's the indices rule that we know about. If powers are equal, we could multiply the bases, right? So this could now be written as 1 plus x. If we multiply the bases, 1 plus x into 1 minus x, that's a squared minus b squared. It's going to become 1 minus x squared whole raised to power 1 over 2. And now this 1 over 2 power could be written in the square root form. And we have 1 plus x into square root of 1 minus x squared. And that is what we had to prove there. This is the gradient of the normal. Okay. Now that was quite tricky. And that is what P3 turns out to be sometimes. But it should not scare you still, because it's a 5-mark question. Okay, it's a 5-mark question. You've already found the derivative here. You have found dy over dx. You have found gradient of normal. Up to this point where you have written the fraction for the gradient of the normal, you get 4 marks already. Okay, you get 4 marks already until this particular point. Conversion to the form that they are asking for, this conversion from that point to this, that's just 1 mark. So even if somebody was not able to figure that out in the exam, it's okay. It should not worry you too much. That just makes you lose 1 mark here. Okay. Before that, until this point, was not that complicated. Yes, it was complicated, yes, but not too complicated. You would still get 4 marks until this point. Okay. All right. Anyway, let's look at the next part now. That was the first part. Now, the second part says the gradient of the normal to the curve. The gradient of the normal to the curve has its maximum value at the point P shown in the diagram. Find by differentiation the x coordinate of P. Now, questions like these actually come in paper 1 as well, although the functions are relatively simpler. This is a more complicated function for which you have to use the quotient rule. But this idea, gradient of something having a maximum value, having a minimum value, they test this in paper 1 as well sometimes. Now let's understand the statement well. Let's try to understand the statement. It says gradient of the normal. Gradient of the normal, that's exactly what we have found in the first part. This is the gradient of the normal. This has a maximum value at the point P. At this point, the gradient of the normal has a maximum value. We need to find the x coordinate of P. Now, remember, we're not talking about the maximum value of the curve here. And you can see on the diagram, there's no maximum value of the curve. There's no turning point of the curve. This point P is not the maximum point of the curve. So it's not that you have to find dy over dx and put that equal to 0. Just looking at maximum value, don't just do this, that dy over dx should be equal to 0. It's not the maximum value of the curve. It's the maximum value of the gradient of the normal. This has a maximum value. So if you were to try to understand it logically from the graph, what they're basically saying is, at any point on the graph, you could have a normal, right? So at this point, for instance, the normal would look like this. At this point here, the normal would look like this. At P, the normal would look like this. The gradient of the normal to the curve is maximum at point P. So it's the steepest. The normal is the steepest at point P. That's what it actually looks like graphically. Okay. Now, how do we actually figure this out now? That's the question. So first thing, don't put dy over dx equal to 0. That would not be correct. So what do we do instead? Let's try to understand that. In the previous part, what we have done is we have found the gradient of the normal. We have found that the gradient of the normal, that is equal to 1 plus x into square root of 1 minus x squared. This is the gradient of the normal. Now forget about the original curve because we're not looking for the maximum point of the curve. We are looking for the maximum point of the gradient of the normal. That means treat this as some new function. Okay, treat this expression as some new function. Let's call this g of x, let's say. What are we calling g of x? The gradient of the normal. We are giving this a new name. We're saying this is g of x. G of x is a function which is 1 plus x into 1 minus x squared whole raised to power 1 over 2. This is the function g of x. The problem is just finding the maximum value of this function. Or in fact, just the x coordinate of that value. X coordinate of the maximum value of this function. So treat this as a new function. Let's say this is g of x, which is a new function. You have to find the x coordinate of the maximum point of this function. How do you do that? You have to find the x coordinate of the maximum point of this function. You would say, find the derivative of this, put that equal to 0. All right. That will give you the x coordinate of the maximum point of this function, which is the gradient of the normal. Okay, now how do you differentiate it? It's a product. uv dash plus vu dash. Again, so u remains as it is. Derivative of this, that's going to be 1 over 2 into 1 minus x squared. Subtract 1 from the power, multiply by the derivative of the power. What's the derivative of this? Minus 2x plus vu dash. Now v remains as it is, 1 minus x squared whole raised to power 1 over 2 into u dash, derivative of 1 plus x, that's just 1. This is the derivative of this gradient of the normal. You put this equal to 0 now, because we're looking for the x coordinate of the maximum point of this gradient. Now we need to solve this equation. Let's see what we get from this. So we have this 2 and this 2, they get cancelled. All right. And what are we left with? Minus x into 1 plus x. And then you have this, which is 1 minus x squared whole raised to power 1 over 2 plus 1 minus x squared whole raised to power 1 over 2. Okay. Now we need to solve this equation. What we can do is we can multiply the whole equation by this thing so that we get rid of the denominator, right? We get rid of the fraction. To simplify this, I'm going to multiply the whole equation by this thing, okay? So that the fraction gets eliminated. Now on the left side, when we multiply by this expression, that becomes 0. On the right side, in the numerator, we get minus x into 1 plus x. And then this also gets multiplied with this. What does that give us? 1 minus x squared raised to power 1 over 2 into 1 minus x squared raised to power 1 over 2. That's going to be 1 over 2 plus 1 over 2. The power is going to become 1. This is what you have. Now let's simplify this. Minus x squared plus 1 minus x squared equals 0. And we get minus 2x squared minus x plus 1 equals 0. And then 2x squared plus x minus 1 equals 0. If all that was not enough, now they want us to solve this quadratic equation. Can we factorize this? Yeah, we can. So it becomes 2x squared plus 2x minus x minus 1 equals 0. And we get two factors, 2x minus 1 and x plus 1, which means x either equals 1 over 2 or x equals minus 1. Now we were looking for the x coordinate of the point P. We can see on the diagram, P is on the right side. right? P is on the right side. So the x coordinate of P is supposed to be positive. It cannot be negative. So this is not P. That's not what we want. The x coordinate of P is 1/2. And that is what we were looking for. All right. Any problem with this? No problems? Okay, just a couple of more questions. It'll take 10, 15 more minutes and then we end. So this is the x coordinate of P, x equals 1/2. Let's do a couple of more questions and then we end. So the next one that you're asking about is, okay, question number 35. Okay, let's try this now. Question number 35 from the worksheet. Okay, so now we have polynomials coming with differentiation. Again, that's another combination that you see coming in differentiation. It's not very common, but it's here now. Let's try to understand this. We have a polynomial, so we've done polynomials, right? The polynomial f of x is of the form x minus 2 whole squared into g of x. So we have a polynomial f of x, and they're saying it looks like this. F of x equals x minus 2 whole squared into g of x. That is f of x. Where g of x is another polynomial. Show that x minus 2 is a factor of f dash of x, f prime of x. Show that x minus 2 is a factor of f dash of x. F dash of x is the derivative of f. Okay? Walaikum assalam. Okay, Abdullah. That's all right. F of x equals x minus 2 whole squared g of x. That's what we're getting. That's what is given. We need to show that x minus 2 is a factor of this thing. Now, how do you do that? You first find the derivative of this, f dash of x. What's the derivative of f? Now, it might look weird right now, but it's actually just a product, right? G of x is another polynomial. That's another expression in terms of x. Okay. So we have one expression, which is x minus 2 whole squared, and we have another expression, which is g of x. They are being multiplied with each other. So it's a product. How do you differentiate a product? Using the product rule, right? This is u, this is v. Derivative is going to be u v dash plus v u dash. That's how you find the derivative. So it's x minus 2 whole squared as it is into derivative of g. What's the derivative of g? That will be g dash of x plus v u dash g of x as it is into derivative of x minus 2 whole squared. What's that? That's the power function. You multiply by 2, subtract 1 from the power, and multiply by the derivative of the base of the power. This is what you end up getting. If you were to simplify this, that's going to be x minus 2 whole squared into g dash of x plus 2 into x minus 2 into g of x. That is what f dash of x as an f prime of x, the derivative of f, turns out to be. We need to prove that x minus 2 is a factor of this. Now, one way to think about that could be that you take x minus 2 common, and that will give you something like this inside brackets, x minus 2 multiplied by g dash of x plus 2 into g of x. Now, since x minus 2 is coming out common outside, that means it's a factor, right? It's a product like this. This is the factorized form of f dash of x. X minus 2 is a factor. This could be one way of showing this. by just taking this common like this, and you say this is the factor. Another way of thinking about this could also be using that remainder theorem that you've done in polynomials. You have to prove that x minus 2 is a factor. What you could do could be just input x equals 2 in this, right? Let me show that to you as well on the side. Another possibility could be that you have this f dash of x, the derivative of f. Another way of proving that x minus 2 is a factor could be using remainder theorem. You could say, let's input x equals 2 in this. When you input x equals 2, what do you get? F dash of 2, that equals 0 minus 2. That's going to be 0 minus, 2 minus 2. Now that is 0. That multiplied by anything is going to become 0. And then you have 2 into 2 minus 2. Again, that's also 0. So that means the remainder is equal to 0. That means x minus 2 is a factor. That could be another way of doing this, using the remainder theorem, that the divisor was x minus 2. So you put x equals 2 in the function. Since the remainder turns out to be 0, that gives you x minus 2 a factor. Okay, so that could be another way of doing this. So you can do it either way, both work. That's the first part. All right. Now let's look at the second part. Part 2. Now, part 2 says the polynomial x raised to the power 4 plus x raised to the power 5 plus ax raised to the power 4 plus 3x cubed plus bx² plus a, where a and b are constants, has a factor x minus 2 whole squared. Okay. Using the factor theorem and the result of part 1 or otherwise. So generally when it says or otherwise, that's, you treat this like the examiner is trying to challenge you that you can try something else if it works for you. But generally, what they ask you to do, just follow that. That's going to be the easiest way of doing that. So the hint that they give, ignore this otherwise, just follow what they're saying. Okay. And that's going to be the easier way of doing whatever they're asking you to do. So they're saying using the factor theorem and the result of part 1, find the values of a and b. Okay. Now, using the result of part 1, how is part 1 related to what they're asking for in part 2? So we have this polynomial x raised to the power 5 plus something, and they're saying this polynomial has a factor x minus 2 whole squared. Now, if you notice, in the first part, they gave us a function f of x, which was of this form, x minus 2 whole squared into g of x. So basically, f of x, this function, had x minus 2 whole squared as a factor, right? So f of x had a factor which was x minus 2 whole squared. You can see that here, that's common outside, x minus 2 whole squared. So x minus 2 whole squared is a factor of f of x. And that's exactly what we have in the second part as well. We have some function for which x minus 2 whole squared is a factor. So that's the connection between the two. Now let's see how we can use that. Let me write that function down here. First of all, the function is, the polynomial is x raised to the power 5 plus ax raised to the power 4 plus 3x cubed plus bx² plus a. And that's the function. And they're saying x minus 2 whole squared is a factor. Okay, now if x minus 2 whole squared is a factor, that means if you were to input x equals 2 in this function, the result has to be equal to 0. Now let's call this f of x or p of x. You can call it whatever you want. If you were to put x equal to 2 here, why x equal to? Because we put the divisor equal to 0. That gives us x equals 2. We can put that value there. That's going to give us the remainder, right? So remainder when we input x equal to, that's going to be f of 2. What do you get from that? 2 raised to the power 5 plus a into 2 raised to the power 4 plus 3 into 2 squared, no, 2 cubed, plus b into 2 squared plus a. This should give us the remainder. Now, since x minus 2 whole squared is a factor, that means this remainder should be equal to 0. So we should equate this to 0. All right. And that gives us an equation. So that gives us something like this: 32 plus 16 times a plus 24 plus 4b plus a. Let's simplify this. And that gives us 17a plus 4b plus 24 plus 32, that is 56. We could take that to the other side. We have this equal to minus 56. That is one equation that we're getting. That's one equation in terms of a and b. We have two unknowns. Since we have two unknowns, we can't really find the values of a and b from this. We would need some other equation as well. All right. Now that's one equation that we have. Okay. That's one equation that we have. Now, what about finding another equation now? So we would need some other equation to find the values of a and b. How do you get that? In the first part, so they asked us to use the first part, right? So we have used the factor theorem to get one equation. They also asked us to use the first part. Now, we talked about this before. What is the connection between the first part and the second part? In the first part, we had a function f of x, and x minus 2 whole squared was a factor of that function. If x minus 2 whole squared was a factor of that function, we proved in the first part, we showed in the first part that x minus 2 should be a factor of f dash of x. If x minus 2 whole squared is a factor of this function, then that the derivative of that function would have x minus 2 as a factor. So what we can do is, if we were to differentiate this function, if we were to find the derivative of this function that we are given in the second part, f dash of x, if we were to find the derivative of this function, which would be 5x raised to the power 4 plus 4 times ax cubed plus 9x squared plus 2bx, and a is a constant, derivative of that is 0. This function, the derivative of that f of x, this would have x minus 2 as a factor using the result of the first part. Because in the first part, we showed that if a function has x minus 2 whole squared as a factor, its derivative would have x minus 2 as a factor. So this derivative should have x minus 2 as a factor. What that means is, if we were to input x equals 2 in this derivative, the result from this, the remainder from this, should also be equal to 0. Let's find the remainder here. That gives us 5 into 2 raised to the power 4 plus 4a into 2 raised to the power 3 plus 9 into 2 squared plus 2b into 2. This remainder should also be 0 because x minus 2 is a factor. Now, let's simplify this. 2 raised to the power 4 is 16. That's 80 plus 8 into 4. That's 32 times a plus 4 into 9 is 36 plus 4 times b. And that gives us 32a plus 4b, 116. We could take that to the other side, minus 116. Now, we could actually simplify this by dividing by 4. If we do that, we are left with 8a plus b equal to 116 divided by 4, that is 29, so minus 29. This is another equation that we have. So this is another equation in terms of a and b. Now, we've got two equations in terms of a and b. We can just solve them simultaneously now to find the values of a and b. All right. That's all that we've got to do now. So we have two equations. Let me write those two equations down here. The first equation was 17a plus 4b equals minus 56. And the other equation is 8a plus b equals minus 29. We just solve these two equations simultaneously. Now, the first one, from the second one, we could make b the subject, and that gives us minus 8a minus 29. Put that in the first equation, and that will give you 17a plus 4 into minus 8a minus 29. That equals minus 56. And you have 17a minus 32a minus, okay, let's do the calculator for this. That's 116 equals minus 56. And that gives us minus 15 times a equals 60. And the value of a turns out to be minus 4. Put that in the other equation. That will give us the corresponding value for b. That's minus a times minus 4 minus 29. And that's 32 minus 29. That's 3. The value of b turns out to be 3. So a equals minus 4 and b equals 3. That is what we were looking for. Okay. I hope that makes sense. Now, let me quickly go through this again. What did we do here? In the first part, we proved that if we have a function f of x that has a factor x minus 2 whole squared, then the derivative of that, f dash of x, would have a factor x minus 2. And then in the second part, we had a function that had x minus 2 whole squared as a factor. Using the result of the first part, we said that f dash of x, the derivative of this function, should have a factor x minus 2 as well, because that's what we proved in the first part. Any function that has a derivative that has a factor x minus 2 whole squared, the derivative of that would have x minus 2 as a factor. Okay, and that's the result that we used here. We said one equation could be got, we could get one equation by putting the remainder from this function equal to 0 when we input x equal to 2. That gives us one equation. And then we find the derivative, put x equals 2 in that as well, because x minus 2 is also a factor of this. And put this remainder equal to 0 as well. That gives us another equation. Solve those two equations simultaneously. And that gives us the values of a and b. Okay, I hope that makes sense. Now, let's quickly look at one last question. This is a relatively simpler one. So 𝗣𝗽𝗻𝗁 asked this question. Question number 8. That was very straightforward. But let's just end with that now. Okay, I think 𝗣𝗻𝗁 has gone to sleep now. But let me just have a look at this question that he asked so that you can watch the recording later on. Question number 8. This is a fairly simple one. At least it looks like it. Let's end with this one now. Question number 8. Okay, then tomorrow we're starting integration, remember. And next week, we might have 6 classes, so be prepared for that, because we are going to try and finish most of the content before the Eid. Okay. So the curve y equals e raised to power x over cos x has one stationary point. Find the x coordinate of this point. So we just have to find the x coordinate of the stationary point of this curve. Now, what's the curve? It's this. How do you find the derivative of this? You can use the quotient rule. What's the quotient rule? Derivative of u over v, that is vu dash minus uv dash divided by v squared, right? That's the derivative of a fraction. Now, what does that give us? We can say this is u and this is v. So v as it is, that means cos of x as it is, into derivative of u, which is e power x. Derivative of e power x is just e power x. minus u as it is, which is e power x, into derivative of cos. Derivative of cos is minus sine. So it's minus sine x. In the denominator, we would have cos square x. Right? Since we're looking for a stationary point, we put this equal to 0. On the right side, we get e raised to the power x into cos x plus e raised to the power x into sine x. Over cos square x. Now cos square x will go to the other side and become 0. All right. So what are we left with? E raised to power x into cos x plus e raised to power x into sine x. We could take e raised to power x common. Inside, we're left with cos x plus sine x. Now that means either e raised to power x equals 0 or cos x plus sine x equals 0. Now the first one does not give us anything because, again, e power something can never be equal to 0. You can try taking log and you would realize you would get undefined on the right side. So this is not possible. From the second equation, we can say cos of x equals, or maybe sine of x equals minus cos. Divide cos x on this side, cos of, it will be sine x over cos x. That leaves us with minus 1 on the right side. It becomes tan of x. Tan x equals minus 1. Find the basic angle. Write this as tan alpha. Tan alpha equals 1. What's the basic angle? Basic angle is going to be pi over 4 in this case, right? Tan inverse of 1 is pi over 4. So the basic angle is pi over 4. Tan is negative. Where is tan negative? Tan is negative in the second quadrant or in the fourth quadrant. So these are the two possible angles that we have. It's either here or here. Now we look at the interval that's given in the question. The interval is from minus pi over 2 to plus pi over 2. Minus pi over 2. So that's minus 90 degrees. This is minus pi over 2. And plus pi over 2. This is plus pi over 2. So basically, interval is this. So that means the second quadrant, therefore, is not possible. That's outside the interval. So we're only going to be looking at this value. Now, this is the interval from minus pi over 2 to plus, minus pi over 2 to plus pi over 2. We would be taking the negative value here, going like this. Okay, so what's the value of x that we get here? We get x equals minus pi over 4. And that's the x coordinate of stationary point that we were looking for. X equals minus pi over 4. So after all those questions that we've done, this was actually quite straightforward. That's what you would do here. Okay, I hope that makes sense. Yes, Abdullah. So if they ask you for a stationary point, a maximum point, or a minimum point, for all of them, you put dy over dx 0. Stationary point is something that could be a maximum or it could also be a minimum. Both could happen when they say stationary point. It could be any one of those two cases. So you can say maximum point and minimum points are just two specific types of stationary points, right? And if you have to find the nature, you find the second derivative and you see if the second derivative is positive, that's a minimum point. If the second derivative is negative, that's a maximum point. Yes. All right. Is that okay? Any problems with this? No? All right, good. So we're going to end this here now. So we did a lot of questions from the worksheet today. So we started with 16, 39, 36, 22, 33, 12, 35, and 8. And some of them were quite complicated. But that's it for today. Tomorrow, we are starting integration. And it's going to be pretty fast-paced because we have very little time left. That means you'll have to do practice questions every single day with that so that you understand very well what you've done the previous day. Okay, so make sure that you are regular with attendance and practicing questions from the worksheet regularly as well. It's considered to be the hardest P3 topic and maybe the hardest topic across A-level maths, across all papers. So be ready for that. There's a lot that we have to do in the next 7-8 days. All right. Okay, I'll see you again in the next class. Allah Hafiz.
Allah Hafiz, sir.
Allah Hafiz.
Allah Hafiz, sir.
Allah Hafiz. Oh, quick revision videos. You can just search in the playlist. Abdul Hadi, you can just search on the channel, quick revision videos. In fact, you go to the homepage, you just go to this homepage. Let me leave a link for that here. You go to this page, and on that page, you would find quick revision videos. There's a section for quick revision videos. You'll find all of them there. All right. I also have this past paper session starting next week. No, after a couple of weeks, we have a past paper session starting. If anyone wants to register for that, you can have a look at my Instagram and on the community page of my YouTube channel as well. You will find the links for that there. I'm posting the registration form link here as well. Quick practice session. I'm not sure what you mean by that. Quick practice session. So you'll find in the playlist. So in the crash course playlists that you have there, P3 crash course and so there are crash course playlists for all of them. In those playlists, at the end of every topic, you'll find a lot of practice questions there. Okay. So everything is there in one single playlist. P3 crash course, you'll find everything there, all the concepts covered, and the last couple of videos of every topic, they will include the relatively more difficult questions from that topic. So you can have a look at that whole worksheet. Okay, all right. I'll see you again next time. Allah Hafiz, everyone. I have this past paper session starting on 13th. If anyone is interested, you can have a look at this registration form link. All the details are there on the registration form. You can find the details on my Instagram as well. I'll leave the link for that here as well. And maybe I'll see some of you there. All right, Allah Hafiz. Yes, Abdul Hadi, the crash course covers the whole syllabus, all the concepts, and a lot of practice questions as well. But as with any A-level subject, just watching the videos is not going to be enough. You will need to do a lot of practice, and that's especially true for maths. No matter how good a teacher, so no, I should not say that. No, whoever you get as your teacher, just watching the videos is not going to get you that grade. You'll have to practice. You have to practice a lot. That's how you do maths. Without practice, it's not going to work. So in terms of concepts, yes, it covers everything. It covers all the different types of questions that you get on each topic as well. But you will need to do a lot of practice yourself. Topical past papers, yearly past papers, you will have to do all of that. Okay, Allah Hafiz. I'm ending the stream here now as well. I'll see you again, maybe another one. Allah Hafiz.